So, you're very welcome to this Saturday session with exam revision on Leaving Cert Chemistry. We will begin this live session in just a moment. So, as I've said, you're very welcome along to today's Saturday session with exam revision focusing on Leaving Cert Chemistry. Today, I'm going to take you through question 4 on the Leaving Cert Chemistry paper. So, our learning intention is to explore the structure of question 4, look at sample topics that come up, hot topics, tips for answering question 4, and then we're also going to complete 2 questions. So, I'll go through 2 full question 4s with you, step by step, how to answer them, tips, etc., before the end of today's session. So, what is question 4 on the Leaving Cert Chemistry paper? So, I always call this the mixed bag exam question. Question 4 is a question that you can be asked any part of the chemistry course, and I would always say that it is made up of the small minor details that are on the chemistry course. The question 4 consists of 11 parts, of which you have to answer 8. Now, we can see then from this on my notes that you will get 7 marks for the first 2 answers that you get correct, and then 6 marks each for your other 6. So, what you will end up with at the end is you will end up with 7 by 2. So, 2 questions will get you 7 marks, which is 14. And then you will have 6 questions at 6 marks, which is 36. And when you add that together, that gives you 50 marks in total. So question 4 is worth 50 marks, as with every question on the Leaving Cert exam paper. And as I've said, topics in these questions will come from a variety of chapters on the course. There's a big emphasis on certain things that we'll see in the next slide, but it mainly consists of small minor details on the course that the examiner really wants to test you on. So what I will be saying is, if you are not comfortable on small details in certain chapters, question 4 may be a question that you wish to avoid. But we'll have a look at the next slide now and see what the hot topics are, and that might help you make your decision. So let's look at some hot topics or popular topics that regularly appear on question 4. So on question 4, you are pretty much guaranteed to get something along an electronic configuration. So that could be a very basic electronic configuration, but at higher level it does tend to be more along the lines of Ionic electronic configuration. So you could be asked for the electronic configuration of sodium 2 plus, or something like that. So just to be aware what the charges do to your electronic configurations, or the number of electrons that are present in your atom. Another thing that's very common, we'll see it today, is chemical formulae. Some of the questions will ask you to write down the chemical formula for a certain compound, or to deduce the formula based on its mass, etc. So that can also include empirical formula. There's lots of definitions on question 4. These definitions range from simple things such as electronegativity, ionization energy, up to and including like autoignition from fuels, primary treatment in the water chapter, all of those definitions, anything along the lines of properties of gases laws, which we'll see further down. Atomic theories are very popular. And with your atomic theories, there you will be looking at Bohr's plum pudding model, the discovery of the nucleus, the discovery of the proton, etc., with Rutherford's gold foil experiment. So all of those pop in there under atomic theories. Next, we can see bonding. Now, when it comes to bonding, you there could be asked to maybe draw a dot cross diagram. You could be asked the shape of molecules, whether they're tetrahedral, planar, trigonal, planar, linear. You could also be asked about intramolecular bonding. So you could be asked about van der Waals forces, dipole-dipole forces, hydrogen bonding, etc. When it comes to flame tests, you could be asked how they were conducted, and mainly you will be asked the colours that the flames show or emit when placed under a Bunsen burner. Calculations are popular in question 4, but what you do need to remember is at most your calculation will only be worth 7 marks. So it can't be a very, very long calculation. It will have to be something short and sweet that can be covered and answered very, very quickly. Same goes with stoichiometry here. So again, they're going to be short, snappy calculations from stoichiometry like parts per million, percentage weight per volume, etc. They can't give you a big long first principles to figure out because it is only worth 7 marks. Next, we can see properties of gases. So here you'll be looking at all of the properties. Gay-Lussac's law of combining volume, for example, Charles' law, Boyle's law, Avogadro's law. They all come up and they can be asked. But you could also be asked a calculation like PV equals nRT. You could be asked stuff in your ideal gas theories and the assumptions of that, etc. In question 4, you are guaranteed to get one part of the question based on the option that you do. Now, I do often say to try to veer clear of the option. Your teacher may not cover it for you in class, and there's lots of other questions that you can do without having to do the option, because the option also appears later on in the paper, but it's part of one of the choice questions as well. Another thing that just popped into my head there is the balancing of redox equations. So you could be asked to assign oxidation numbers and balance an oxidation reduction equation as a result. So there, a list of the hot and popular topics in the question. This list is obviously not exhaustive. There's a question that we come across today that's on rate of reaction that's not listed there. But these ones I've gone with are the ones that come up most often and most frequently to help you study for the question 4. So, some top tips when you're answering or approaching question 4 on the exam paper. I would always say that, first of all, read the question, and from there, answer as many parts of this question as you can. There's no such thing as negative marking in the question 4 or at all on the chemistry paper. So for writing down the answer, you won't lose marks. So that's why I would always say there is 11 parts. You should answer 8, but if you can answer 9 or 10, that does give you a cushion that if you lacked detail in another part of the question, you would still be able to get full marks. So marks will go for your best 8. So if you answer 10 questions, one of them is wrong and 9 of them are correct, you get full marks. If 2 of them are wrong and 8 of them are correct, you get 50 marks or get full marks. So it's just that extra or answering as many questions as you can gives you that extra buffer that you might need to allow you slip up elsewhere. That's why I would always recommend to attempt as many questions as you can in question 4. So next, only attempt question 4 if you are able to answer at least 8 parts. If you don't, if you're only able to answer 7 parts, you're automatically down 6 marks. So that brings you down to 54. So the more questions you answer, or the more parts of the question that you answer, the higher the capability is to get full marks in this question. So if you read through it and you're like, oh, I can only definitely answer 7, don't do the question, because you're automatically putting yourself at a loss. Your H1 will automatically be lost in that question, so you may be better off to go elsewhere and try and get as many marks in another question as you can. Lastly, it's important to read the questions carefully, as answers will need to be specific and to the point. So question 4 is not a question for you to go waffling. It's not a question that you can just babble your way through the answers and hope for the best. They need to be precise and to the point. They're either right or they're wrong. So you need to make sure, as I've said, if you are doing this question, that you can answer at least 8 questions, if not more, to give yourself that little safety blanket. So that's all kind of like the theory and the tips and stuff out of the way for question 4. So I thought it would be best use of our time today to go and do some examples of exam questions. So we're going to look at the 2020 paper and the 2021 paper. We're going to look at them, we'll go through them, and along the side I've created a table of the topics that were seen that year in question 4. So feel free, if you wanted to pause this video, to go and try and do 2020 and 2021 and come back and correct it as we go through it. Or you can just take out a sheet of paper or a copy and start doing out this question with me, and we'll work through it together so that we can all have a better understanding of what question 4 entails. So here we can see the 2021 question 4. So I have the question here on the screen on the left hand side. So what we're going to go through now is, before we actually start answering the question, we're going to read through each part and see what chapter or what part of the course it belongs to, and if there's any hint or tip I can give you to help answer that part. So let's dive straight in. So if we take a look at part A, we can see that part A asks us how many electrons and neutrons does an ion of sulfur 2 minus have. Now that clearly comes from atomic theory, because you're looking at the number of protons, neutrons and electrons present in the atom. Part B then asks you to define an atomic orbital, and that comes from the atomic theory chapter as well, and it is a definition. So that would be something that needs to be known word for word, will be very specific, and we'll go through it in a second. Part C asks you to write the SPD electronic configuration for a nickel atom in the ground state. So there's a few key pieces of information. We are looking at the SPD electronic configuration, and we're looking at the nickel atom, and it's in the ground state. So that is coming from your electronic configuration chapter. Part D then says that the diagram shows 3 containers, each filled with a different gas, and each container holds the same volume of gas at the same temperature and pressure, which contains the largest number of atoms, and it asks you to explain. A tip I'll give you: if you see the words same volume, same temperature and pressure, or if you even see the words volume, temperature and pressure in the one question, you are realistically looking at a property of gases question. So that's what we have in part D. So part E then asks you to define electronegativity. So that is a definition that it comes from the bonding chapter. Part F, it asks you to take the average bond energies of a carbon-carbon single bond and a carbon-carbon triple bond as shown. And they ask, why is the average bond energy of the triple bond less than 3 times the average of the single bond? So that obviously comes from the bonding chapter, and we'll explore the answer to that in just a moment. Part G then, it says 2 volumes of an oxide of nitrogen decomposed in the presence of a heated catalyst to form 2 volumes of nitrogen gas and 1 volume of oxygen. All volumes are measured at the conditions of the same temperature and pressure, and it says use this information to deduce the formula of the oxide of nitrogen that decomposed. So this would be looking at chemical formulae, and we'll have a look at that in a moment. Part H says the use of KBROX as a flour additive has been banned in the EU for many years, but it is sometimes used to bleach flour and strengthen the dough. So they tell you that bromine is 47.9% by mass of the whole formula, and they ask you to find X. So that is a stoichiometry calculation there. Part I says show by means of an equilibrium equation the self-ionization of water that occurs even in deionized water. So that is coming from the equilibrium and the water chapter. Part J says give a use that propanoic acid, benzoic acid and the salts of these acids have in common. That's coming from your organic chemistry. Part K then asks what is the average number of electrons shared between any 2 adjacent carbon atoms in a molecule of cyclohexane and benzene. That's going back to your bonding. And then part L is from the option. So as you can see there's quite a wide variety of topics that are present in this question, and they are all very particular questions that you need to know the answer directly and to the point. So let's go through some of those answers now. So let's go through some answers now to these questions, and we're going to start with part A. And part A, as I've said already, is from the atom chapter, where we're asked to identify the number of electrons and neutrons present in an ion of sulfur. So we can see here that we have 32, 16, S2 minus. So that 2 minus charge means that this atom has gained 2 electrons. So we can see that the atomic number is 16. So 16 plus 2 means that there is 18 electrons present in this ion. And we can see that the mass number is 32. So the mass number tells us the number of protons and neutrons. Now, we know from our atomic number that there is 16 protons, and we know that because this 2 minus negative charge that's here doesn't affect the number of protons, it only affects the number of electrons in the atom. So I know that there's 16 protons in this atom. So if the mass number is I'll just write that down there. Mass number is protons plus the neutrons. I can do 32, take away 16, and that will leave me with 16, which would mean that there is 16 neutrons, because I've gotten the 16 here from the atomic number of the atom. So that is part A. Part B then is a definition. And it is the definition for atomic orbital. And we know that an atomic orbital is the region of space around the nucleus of an atom where there is a high probability of finding an electron. So the keywords that you would have needed to have that year, according to the marking scheme, is you would need region, high probability of finding an electron. Okay, so important to note the word region. The word area was not accepted in that year, so important that you use the word region. So part C, we've said that this is an electronic configuration question, and it asks you to write the SPD configuration of the atom of nickel. Now, we know that nickel has an atomic number of 28, and you can get that on the periodic table. So that means you have 28 electrons that you need to fit into this atom. Now, we know that our order of our atomic orbitals is 1s, 2s, 2p, 3s, 3p, 4s, and 3d. So that will be the order of the atomic orbitals. Now we're probably not going to fill all of them, but let's have a look. So we know that the first orbital can hold 2 electrons, so it'll be 1s2. We know the s can hold 2, the p can hold 6, and the d can hold 10. So we've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and let's stop there now. I can see at the minute I filled in 20 electrons. 2 and 2 is 4, and 6 is 10, 12, 18, 20 in total. And we've 28 in the atomic number, so that means there is 8 electrons in the 3d orbital. So that's part C. Let's move on then to part D, and we said that part D came from the properties of gases chapter, and it is specifically linked to Avogadro's law. So if we read the question carefully, a key part of the question here is that each container holds the same volume of gas at the same temperature and pressure. So that would ask which contains the largest number of atoms. So according to Avogadro's law, because the containers are at the same volume and same temperature, it would be the CO2 container that contains the largest number of atoms. And that is because the CO2 molecule has a carbon and 2 oxygens in it. So what we could say there is we could say equal number of molecules and CO2 has 3 atoms in every one molecule, very basically. Let's move on to part E. Part E asks you to define electronegativity. So electronegativity is the relative force of attraction an atom has for the shared pair of electrons in a covalent bond. So part F is linked with bonding. It says take the average bond energies of a carbon-carbon single bond and a carbon-carbon triple bond. And it asks why is the average bond energy of the triple bond less than 3 times the average bond energy of a carbon-carbon single bond. And the reason for that is your carbon-carbon single bond consists of one sigma bond, where a carbon-carbon triple bond contains one sigma and 2 pi bonds. And we know that sigma bonds are stronger than pi bonds. So because they're stronger than pi bonds, because sigma bonds are stronger than pi bonds, they would hold the atoms closer together. So because it's not 3 sigma bonds in the C single bond C, that would affect the bond energy as a result. So next we've got part G, and part G is asking you to deduce the formula of an oxide when you are given some information about their volumes and how they decompose. So first thing it says 2 volumes of an oxide of nitrogen decomposed in the presence of a heated catalyst. So you're definitely going to have 2 of whatever your oxide is, and you're told that that decomposes, which means breaks down. So it breaks down to form 2 volumes of nitrogen gas. Now we know nitrogen gas naturally exists as N2. So you've got 2 N2 and 1 volume of oxygen gas plus O2, because we know oxygen exists as O2. All volumes are measured at the same condition of temperature and pressure and use this information to deduce the formula of the oxide that decomposed. So what we can see here is that we have 2, on your product side, you've got 2 nitrogen molecules, so that means there's 4 nitrogens. Now, you're told 2 volumes of an oxide of nitrogen breaks down. So if you've got 2N2 on the right-hand side, you're going to have 2N2 on the left. Now, we know that this oxide breaks down to form oxygen gas, which is O2. Now, we have 2 moles of our oxide, or 2 volumes of our oxide. So if I put in O there, like that, that would mean this will be now balanced, because 2 by 2 gives me 4 nitrogens and 2 oxygens gives me O2. So that means that the answer for this question, the chemical formula of the oxide of the nitrogen that's decomposed, is N2O. So basically what you're doing is you're working backwards on a balanced equation there. Part H then, as I've said, this is a stoichiometry calculation, and you're told the use of KBRO as a flour additive has been banned in the EU, and lots of information about that. The main bit that we want to see is down here. It says KBROX contains 47.9% bromine by mass. Find the value of X. So what we can do here is we know that we have 47.9% mass of bromine. Now, we know that if we want to find the percentage of an element that is present in a molecule, what we can do is we can do the mass element, so in this case it would be the mass of the bromine, over the mass of the molecule, multiply that by 100. That would give us the percentage. So we know here that the mass of bromine is its atomic mass, and we need to find the mass of the molecule. So let's just look at that quickly. So we've got 1 potassium, so that would be 39. We've got 1 bromine, that would be 80. And then we have X oxygens, so that would be 16X. So now, if we fill into our formula, the mass of bromine is 80 over the mass of the molecule will be 39 plus 80 plus 16X, and that will be multiplied by 100, and that will give us 47.9. And now, from this, we can go and figure out our X value to find how many oxygen atoms there is present in this molecule. So what we will get is we will get 80 over 119 plus 16x. That will be multiplied by 100, and that's equal to 47.9. So I'm going to do all the multiplication and cross multiplying together. So that will give me 8,000, because the 80 by 100 is equal to 47.9 by 119 plus 16x. So if we go and work that out, what you will get is, you'll get 8,000 is equal to 5,700.1 plus 766.4x. So that gives us 766.4x is equal to 2,999.9, and then dividing by the 766.4 gives us that x is equal to 3. So that is your answer for that part. So moving on to part I. Part I asks you to show by means of an equilibrium equation the self-ionization of water that occurs even in deionized water. So we want to basically look at how water can self-ionize. So with this, you're looking at H2O, and if it self-ionizes, it will go and form H plus and OH minus. The other option is, you may know that the H plus ion doesn't readily exist, so it could form a H3O plus ion and OH minus. But if you decide to use that equation, you must have two H2O at the start in order for it to be balanced. So that's part I. Next, on to part J. It says give a use the propanoic acid, benzoic acid, and salts of these acids have in common, and they are all used as flavouring agents. Part K then, it asks you what is the average number of electrons shared between any adjacent carbon atoms in a molecule of cyclohexane or in a molecule of benzene. So for part 1, for cyclohexane, the number of electrons shared between the adjacent carbon atoms is 2. And for benzene then, it is 3. And that is got to do with the type of bond that we have in our two molecules. So in cyclohexane, which is fairly easy, we know that a bond has 2 electrons. So let's say, for example, if we take this carbon here and this carbon here, there would be an electron on each end being shared there. Where with benzene, we know we have delocalized electrons. So if we were looking at this carbon here and this carbon here with the 2 blue dots there would be 1 each from the bond, but there would also be 1 donated from the ring, because that ring shows 6 delocalized electrons. They don't belong to any one carbon. They are moving around in a cloud. So part L then is your option part of the question. And the option that I usually cover is always option A. And option A here asked you to give one advantage and one disadvantage of using batch process in chemical industry. So it's important before we answer this question that you understand what batch process is. And when you do this option on the course, you speak about batch process and continuous process. So batch process is one in which there is a series of operations carried out at a separate time, one after the other, where a continuous process is where all of the operations for production occur at the same time. So some advantages then of batch process is it is suitable for slower reactions, that it is flexible, so you can stop, start, or change the process at any point in time. But a disadvantage would be that it can lead to contamination, and the labour costs are quite high. It's quite costly to use batch process because the reaction vessels need to be emptied and cleaned each time you're doing a new process. So that's the 2021 question 4 done for you. So let's move on now and do another one, the 2020 question 4. So you can see here I've done the exact same as we've done for 2021. I've taken the question and beside it I've put down the topics that each of the parts belong to. And as you can see, there's some familiar topics that we've already looked at. Atomic theory for part A, electronic configuration for part B. Radioactivity has come up in part C in question 4 in 2020. Chemical formula came up again in part D. We had bonding again in part E. Part F was properties of gases. Part G was rates of reaction. That didn't appear in 2021. Neither did electronegativity in part H. Water came up again in part I. Part J was organic chemistry, and part K was the option. So let's go through each of these parts of the questions now, look at them and come up with the solutions. So let's start with part A. So part A asks you to draw a labelled diagram of Thomson's plum pudding model. Now this comes from atomic theory, and you should know that Thomson's plum pudding model is a mass of positive charge with negative particles embedded in it. Okay, now a key part for this question is draw. Okay, so it would be expected that you would draw this diagram, okay? But as with any diagram, if you draw it, you must ensure that it is labelled. So I would be labelling this positive mass, and then I would be labelling this negative particles embedded. Okay, and that's got you covered. But make sure you draw the diagram because that is what is expected in that question. Part B then. Part B says the diagram represents the 10 electrons in the 4s and 3d sublevels of a neutral atom of the ground state. What is this element? So first of all, if they're showing you just the 4s and the 3d, that would mean that all of the sublevels prior to that are full. So the electronic configuration of this atom would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we've got 3d, and it's 1, 2, 3, 4, 5, 6, 7, 8, 3d8. So what we need to do is, we need to go and we need to find an atom that has an atomic number or has 28 electrons present in it. So if there's 28 electrons, that must mean that the element is nickel, N-I-K-E-L, nickel. So part C is radioactivity, and for radioactivity, here they're looking for an alpha nuclear reaction. So I always think it's worthwhile just writing out the full reaction and then looking at what your answer is, because it asks you what isotope is produced, but it's much clearer if you just write it all out. So here we have 241 americium. Now we know if we have an alpha nuclear reaction that we release an alpha particle, and we know that an alpha particle is made up of 2 protons and 2 neutrons, or a helium nucleus. And when you're doing an alpha nuclear reaction, the numbers on the mass and atomic number on the left hand side should be equal to the sum of the mass and atomic numbers on the right hand side. So if I have lost 4 from my mass number on the right hand side, that must mean it is 237, and consequently I've lost 2 from my atomic number, so it will become 93. Now, because our atomic number has decreased by 2. That means that we have lost 2 protons and 2 electrons. So that must mean that the element is now 2 steps to the left on the periodic table. And the element that's 2 steps to the left of americium is neptunium. So to answer this question, what isotope is produced when the nucleus of an americium atom releases an alpha particle? It is this. It's 23793 neptunium. So that is your answer for part C, and it will be important to make that very clear when you're writing down your answers. So part D says, write the chemical formula for magnesium sulfite and copper oxide, copper 2 oxide. Now what I will be saying for this is this relates to your group ions that you would have learned off. So the first thing you should know is that sulfite is SO3 and it has a 2- charge. So we know magnesium has a +2 charge. So that would just mean that it's MgSO2. So your answer there is MgSO3. And then you're looking for copper 2 oxide. Now, if we're looking at copper 2, that's looking at copper 2 plus. Okay, and we want to add oxygen to it, but we know oxygen has a 2- charge. So the charges there are balanced. So your chemical formula for copper oxide would be CuO. Okay, so that was nice and easy. Part E then, you're looking at 2 possible shapes of a covalent molecule with the general formula QX3. So here they are looking at geometric shapes in the bonding chapter. So if you're looking at QX3, so with QX3 there is 2 possibilities. So you can have a possibility with one set of lone pairs, or you can have an option with no lone pairs. Now, if there is no lone pairs present, then the structure is trigonal planar. And if there is a pair of lone pairs present, then it is called pyramidal. Okay, and the reason that they're different is the set of lone pairs causes lone pair repulsion, bond pair repulsion, and lone pair bond pair repulsion. So that all comes into play there. So because of the lone pair, the geometry or the size of the angles between the bonds will be slightly decreased due to the lone pair bond pair repulsion that will be present in a pyramidal structure that would not be present in a trigonal planar structure. So for parts A to E now, in this question, I'm going to assign the marks to show you where your marks were going. And I'm going to do this in green pen. So for part A, there was 6 marks going, 2 by 3 marks there. And that was basically 3 marks for your positive mass and 3 marks for your negatively charged particles that are embedded. And again, you wouldn't get your marks there if you didn't draw the diagram. For part B, it was an all or nothing question. You got 6 marks, and if you identified it as nickel, if you identified it incorrectly, you got 0. So for your alpha nuclear reaction then in part C, there was 6 marks going. There was 3 marks going for your figures of 237 and 93, and then there was 3 marks going for the neptunium chemical symbol. For part D, again, all or nothing, it was 3 for the first part and 3 for the second part. So if you got the structure of the magnesium sulfate wrong but got the structure of the copper oxide correct, you'd still get 3. Same then again for part E, there was 3 marks each for pyramidal and trigonal planar. So if you got one wrong and the other right, you would still get 3 marks. So let's continue with the next few parts of the question, and we'll go back to the marks for those once we have them completed. So part F is a property of gases question. So if we read through it, with properties of gases, you could be looking at Charles' law, Boyle's law, Gay-Lussac's law of combining volume, or you could be looking at the ideal gas law. Now, a top tip I would have for you here is if you look at a properties of gases calculation question and it says or mentions moles, you are going to be using the ideal gas law, which is PV equals N or T. And if you take a look at the question that's here, we can see in part F that they do look for, or they tell you about the number of moles. So that means you are going to be using your ideal gas law. So when we're doing this, I always write out each part of the formula and I try to fill them in. So we read through the question. Is there a pressure? No, pressure is what you're being asked to calculate in the question if we check. So it's P. V is for volume, so we can see that it's 1 by 10 to the power of minus 3 meters cubed. We can see that the temperature, it's already in Kelvin, so it's 293. It will be important to check that that is in Kelvin when you are doing the question. And then R is the universal gas constant, and the universal gas constant is 8.3. And that will always be given to you on the front of an exam paper. So you don't have to learn it off. If a calculation on properties of gases comes up and you're required to have your R value, it will be given to you on the front of an exam paper. N stands for number of moles, so that is 0.36. So if we fill that in now, we can see we have P by 1 by 10 to the power of minus 3 equals N is 0.36, R is 8.3, and T is 293. So you're just filling in. Now we want to get P in its own, so we can divide both sides by our 1 by 10 to the power of minus 3. So that would give me that my value for pressure would be 8.8 by 10 to the power of 5, and the unit for that is pascals. So that was a lovely easy part F once you were able to spot the rule. Part G then, it says how can a catalyst lower the activation energy of a reaction? So we know that activation energy is the minimum amount of energy required for a reaction to take place. So a catalyst can lower the activation energy because it can provide an alternative path for the reaction, which means the catalyst will lower the activation energy, lower the amount of energy that's needed for the reaction to occur, so an alternative path is found. Part H then asks you, under what circumstances do ionic compounds conduct electricity? And ionic compounds can conduct electricity when they are dissolved in solution. So if they're in an aqueous solution or dissolved in a solution, or if they are molten themselves. And if they are molten, that just means they are in the liquid state. Part I then comes from the water chapter, and it says to identify the compound that is the main component of the limescale deposit in a kettle used in a hard water area. So here they're simply asking you, in all of that fancy terms, what causes limescale. And we know that the main source of limescale is calcium carbonate, CaCO3, calcium carbonate. Right, so let's assign the marks for these questions. So for part F, it was your properties of gases calculation. So there was 3 marks for getting to the second last line, and then there was 3 marks for getting your answer. Now, if you gave the formula PV equals nRT, you would probably pick up 3 marks there either. Part G then was on the catalyst, and that was an all or nothing question. It was 6 marks or 0. Part H then, there was 3 marks for saying that the ionic compounds conduct electricity in solution, and 3 marks for saying they conduct it in molten state. So for example, if you left out in solution, but you said molten, you would still get 3 marks. Part I, all or nothing for your main component in limescale, it was either 6 or 0. So let's finish off this question now before we assign the marks to the rest of the parts. So the next part we want to do is part J, and this is focused on organic chemistry. It's focused on the vanillin structure, and it asks you to copy the structure of vanillin into your answer book, and they ask you to circle the aldehyde group and to write the molecular formula of vanillin. So I've just copied the structure there, and what we need to do is we need to circle the aldehyde group. Now, we should know from our studies of organic chemistry that the aldehyde group is a C double bond OH with an OR group or an alkyl chain attached to it. So that would indicate to me that this here that I'm circling on the top right hand corner of our structure is our aldehyde group in our vanillin. Now, a key way to remember the functional group for the aldehyde, it's aldehyde, is that the aldehyde has a H in it, and the functional group of the aldehyde has a H on the end. So your aldehyde functional group can only go on either end of your chain. It can never go in the middle, and it must always have a hydrogen attached onto it. So that's the first part, that's part one. And then it asks you to write the molecular formula of vanillin. So when you're writing the molecular formula of a compound, all you need to do is you need to count the number of each type of atom that is present. So there's two possible answers here that you could have for this question. So the first part would be literally just to write it out as you see it. So I can see that at the centre I have a benzene ring, so that would have 6 carbons. Off that is then 3 hydrogens, 1, 2, 3, so I could write C6H3. Then off that we have a CH3O. Okay, that's here, CH3O. We also have our aldehyde group, CHO. And then we have an OH substituent. Now, you should remember from the fuels chapter when we spoke about substituents that when you're labeling or naming any sort of molecular compound in organic chemistry, you always identify the longest carbon chain. So that's why we would be saying that the OH here is a substituent. The other way you could do it is you could just simply count the number of carbons that there is. So there's 1, 2, 3, 4, 5, 6, 7, 8. So you could say C8, count the number of hydrogens, it would be H8, and that's coming from 1, 2, 3, 4, 5, 6, 7, 8. And then you would just say O3. 1, 2, 3 for my oxygens. So you can do that either way. The first one gives you a little bit more idea of what the structure looks like, but the second one is perfectly fine as well by just grouping all of the like atoms together. So the last part then is part K, which is the option, and I always do the industrial chemistry option, so that here is B of this question, and it asks you to draw the structure of the monomer used to make polyphenylethene. Now, what I would say there is you're being asked to draw a monomer. First of all, that a monomer means 1 unit, so you only need to draw 1 unit of this phenylethene. Poly just means that there will be multiple of those then bonded together. But you don't have to worry about that in this scenario. You just need to draw a monomer. So it's polyphenylethene. So we know that ethene is always going to be a C double bond C. And then it tells us that there is a phenol. So there must be a phenol group off it. So a phenol group is C6H5. And then the rest of the bonds around the carbon, knowing that it must have 4, can just be filled in as hydrogens. So that there is a monomer of polyphenylethene, because you've drawn in your ethene, your C double bond C, and you've drawn in your phenyl substituent, and the rest of the free bonds around the carbons are filled with hydrogens. Let's just assign the marks then for those last two parts. So for part J, there was 3 marks for circling your aldehyde group as requested, and then there was 3 marks for either of these chemical molecular formulae. And then for part K, it was a 6 mark all or nothing for the chemical structure. So that is the 2020 question 4. So just before we finish up, I just want to show you what the Leaving Cert Chemistry exam revision website looks like. So as you can see here, I have all the units of the Leaving Cert Chemistry course done out for you, units 1 to 11, and there's also a folder there on exam preparation. So for example, if we click into the oxidation and reduction section of unit 6, we can see that I have 5 videos here on all of your oxidation reduction titrations. Those videos go through the experiment, the method, common exam questions, and any calculations. And there's also a Leaving Cert Chemistry sample solution done out for you for an exam question of that experiment. You can also see that there is a self-correcting quiz, a PowerPoint presentation, and of course the H1 standard notes. There is also an area where you can build your own exam to test yourself on the titration questions or any part of the Leaving Cert Chemistry course, and marking schemes are also provided. So the standard plans on ExamRevision.ie are $19.99 a month, and premium plans are $29.99 a month. And for today, on this Saturday session, if you wish to sign up to a standard or premium plan for Leaving Cert Chemistry with exam revision, you can use the discount code LCChem20, and that will get you 20% off. So if you need any guidance for Leaving Cert Chemistry, don't forget you can get in touch with us here at Exam Revision. We're on Twitter, Instagram, TikTok, Facebook and YouTube. And of course, you can visit our online learning platform, ExamRevision.ie, where you will get access to the full Leaving Certificate Chemistry course done out in video format, H1 standard notes, PowerPoint presentations, and of course self-correcting quizzes and access to previous exam papers. So that's it for today's Saturday session. Thanks for joining in, and hopefully we'll see you at the next Saturday session very soon.